We're going to be just chatting about deploying your first smart contract. I know smart contracts, they're super crucial to just like the Web3 ecosystem, especially with like dApps and things like that. Sometimes they can get a bit esoteric because, you know, people think that you just have to be this super genius to do it. And it's a lot of times it can be straightforward, but it's a complex process. But I think just knowing how things flow and how things work, it'll make things a little bit less intimidating. So here's a few things that we're going to actually cover. We're going to cover what is a smart contract. We're going to cover how to actually deploy a smart contract. And then we're going to cover how to interact with it. So you'll be able to see everything. I'm going to try not to bore you guys with too much code because, you know, I don't want to get too in the weeds about certain things. But a little bit about me, who I am. I'm Orlundo Hubbard. I am a Web3 engineer here at WRST Collabs. Shout out, I'm wearing a shirt today. Yeah, I got into engineering about a year ago, and I got into Web3 about 7-8 months ago. I minted an NFT called Devs Revolution and became a part of this DAO called Developer DAO. One of my Genesis like Web3 friends is here right now, Josh right here. We started in this thing together. And honestly, I was hooked after that. I was hooked and I just kind of like leaned in. That NFT kind of just accelerated my learning journey and just like the space and just engineering in general. So I kind of been on the train since. 7-8 months is a pretty long time in crypto. I see a lot of people that are spirited, that are new getting into crypto, and I'm just like, oh man, what to be young again? Like, you know, you see these people, it's like, dang. I remember when I first got into it. So we'll go ahead and hop right in. So we'll talk about what is a smart contract. So basically, smart contracts are self-executing code that is sent to the blockchain that completes the transaction. So when you're working with these dApps, when you're working with these products that people are putting out, there is some code that goes to the blockchain that makes it immutable, that it gives it the functionality for you to be able to actually work with that dApp. Self-executed mean that once it's deployed, nobody has to go back and try to change things or fix things to make them a certain way, because the code is going to run by itself. So you don't have to worry about it doing things that are unnecessary unless you actually tell it to do certain things that are unnecessary. So that's just a high-level overview of what smart contracts are. So a few of the benefits of smart contracts are they're permissionless, they're trustless, and they're immutable. I know we hear the word permissionless like a lot in the Web3 space because it is something new for creators and artists and just everybody alike, that we now have an opportunity to join in without having to ask for permission from these big companies, the big boys, the ones that we know. I'm talking to you, Facebook. Permissionless is the first one. So we don't have to wait for centralized entities to pretty much tell us what we are able to do. So of course, traditionally you can get on these platforms, and we're not fully away from it yet, but we're still working on it. We're getting there to where we have these platforms where people can build on top of, and they don't have to be worried about somebody being able to say, well, nope, I'm shutting the server down. All your data is gone. All of your, you know, everything that you've built is gone. We've seen it a few times with YouTube, taking down some of Bankless's content and things like that. So this is a huge problem because, you know, when you are building and making these platforms this much money, the amount of money that we're making them, for them to be able to just have that much power to say, nope, I'm shutting it all down. I think we have a chance to change that with what we're doing with the Web3 space and smart contracts and things like that. So the second thing is that they are trustless. So meaning we no longer have to trust the person that we're actually making transaction with, outside of just like maybe social things like that. But we don't have to trust people that we're actually making, you know, certain purchases and transactions with. Only thing that we have to do is trust the code. There's something that we say as engineers in the blockchain spaces, the code is law. So that means that, hey, these smart contracts that we're writing are actually going to provide the intermediary. So no third party has to come in and say, yeah, this transaction is clean, this transaction isn't. The code that we write and that you send to the blockchain is gonna do that for you. So that's why you see a lot of industries that have middlemen, you'll start to see them actually being disrupted by blockchain because you no longer have to have that intermediary person. You have just the code now. And then the third thing is immutable. So this is why it is super important to at least understand, even if you're not a developer, maybe you're a product person, maybe you're just somebody who wants to put out an NFT project, and you need to verify and make sure that the code that they're deploying is accurate. This piece right here, it being immutable, is super huge because once the code is actually deployed to the blockchain, there's no change in it. Now, essentially, that is supposed to be the rule. There are some ways around that, but as a general whole, there's no change in it once it goes to the blockchain. So making sure that things are secure, that's why you have these audits that are thousands of dollars and they take a long time because they really have to thoroughly check and make sure that these smart contracts are well written. If not, you can cost people millions, and we've seen it cost people millions and thousands and millions of dollars. So that's kind of just a high level overview of what smart contracts are and a little bit about how they work. There's of course some deeper diving that you can go into it, but again, from a general high level overview, that's pretty much what they are. So we're gonna actually jump right into some code. Now, I am gonna do this out of an IDE. I'm sorry, out of the browser. This is called Remix. It's an in-browser IDE, meaning that I don't have to pull up a text editor, a code editor, or anything like that. I can just go straight from here. And I think this is, if you're interested in actually learning smart contract development and how they're actually deployed, I would recommend starting here first because you don't have to worry about setup and all these type of things. I'm not sure who in the crowd is technical or anything like that, but if this was something that you wanted to do, I would start right here. Just want to make sure everybody can see. Okay, it looks pretty legible. So I put together this contract. I was gonna do it like from scratch, but I was like, you know what? I don't want to confuse people. I don't want people who may be non-technical in the crowd to get lost. So I have something pre-made, pre-ready right here. It's a simple contract, just a fee collected contract, almost like an escrow a little bit, where we'll be able to actually receive money. We'll be able to withdraw the funds, maybe send it to other addresses and things that we may want it to go. So let's actually jump right into it. So I have this contract here. It's a fee collector. And then I have this address. This address is a keyword, meaning that, hey, I want you to recognize that what's going to be stored in this is someone's address. So this keyword address right here, and then you have the keyword public, meaning it's public. So if anybody, once the contract is deployed, if anybody wants to go and take a look at that function or that variable, they can. If they want to call it, they can. The next variable that we have here is the UN256. So it's an unsigned integer, meaning I'm telling my code that this is going to actually be a number. So what's going to be stored in this is a number, and then I want to make it public, and this is going to be the balance. So whatever is sent to this contract, because this contract is going to collect fees and things like that. Whatever is sent to this contract, we want to be able to see how much money or how much ETH or whatever we're sending into this contract is sent into there. This next line is a constructor, what's called a constructor function. And functions are pretty much just, if we think about how we interact with our phones and things like that, they're all based off of functions. It's all functionality. It's all something behind the scenes that's telling, hey, when this person presses this button, make sure that this thing happens. So this is the same type of thing. I'm saying this constructor function is a type of function that gets run as soon as the smart contract is deployed. Every other function can be what's called called, what we say called, meaning you can actually go, you have to press it, or you have to fire it first for it to actually for it to be useful. But in this constructor function, it actually fires initially. It doesn't need anybody to say, hey, once this button is pressed, then actually start working. So inside of this constructor function, we have the owner variable. And what we're going to store in it is what's called a method called message.sender. So a message.sender is basically saying that in this owner variable, I want to store whatever address that this contract is deployed with. So every time you deploy a contract, an address is you're using an address to deploy it. So this is the contract, this is the address that is going to be stored in this owner variable when I actually deploy the contract. This is recognizing that, hey, this hash right here is the owner of this contract. That's the person who actually deployed the contract. So the second function is the receive function, because if we just had this constructor function and we deployed the contract, it pretty much wouldn't do anything. Only thing that we'd be able to do is actually see that who is the owner of this contract, and that's not super useful. So to make this actually work and to make it worthwhile, we create this receive function, and it's basically gonna be a payable function. A payable function. The key word here, payable, means that basically this contract can actually receive money. It can actually receive funds, and they want to make it external, so you can be able to see it. And then inside of that function, we're going to place the balance. It's going to be plus or equal to message.value. So we want to be able to show what the amount is when somebody sends money to the contract. The next function that we're going to have is the withdrawal function. Now, this function is super important because without this function, just having this receive function would kind of be useless. Because if you couldn't actually withdraw money out, then you kind of just have money locked into smart contracts. And we've seen situations where millions of dollars get locked into smart contracts because poorly written code. So having this in here is super important. You want to make sure that if your contract does, if you expect to actually take funds out, you want to make sure you have a function like this. It doesn't necessarily have to say withdraw, but just some type of function where you can actually take that money out. And you want to pass into it, meaning you want to say, hey, this can take in an amount, and it can be payable. So I'm going to assign that payableness to this destination address. So if I ever wanted to send it to another address, I want to be able to withdraw that money and then send it somewhere else. If I want to send it to a different address, somebody sends me their address, I can send it there. And then we're going to make it public, which sounds kind of counterintuitive, but what we're going to do to make sure that nobody can call this function, not just anybody, we're going to pass in a few checks. So we're going to have two checks here. One check is going to be the require, and that's what this keyword is basically saying. Hey, make sure that this happens. We're going to say, make sure that the message.sender is the same as the owner. So you remember when we created this owner variable up here? Now what we're saying is, hey, make sure that this address matches the same as that owner. And then if not, this is what this comma is for. If that doesn't add up, or if that doesn't make sense to this contract or to the code, send this error message. Only the owner can withdraw. So the second check that we're going to have is making sure that the amount is less than or equal to the balance. So you don't want to be able to go in a contract and pull more than what's in there. Because think about it, if you go to something like a bank, if you try to go in and take more funds out than that's actually there, it's going to tell you that, hey, you don't have the funds to do that. So we're going to make sure that whatever is being taken out is less than what's already in there, or at least equal to what's in there. And if not, give them an error that says insufficient funds. And then we're going to say destination, the address to dot transfer, meaning, hey, we can transfer this, and then we can transfer the amount. And then we want to make sure that we balance minus or equal to amount, meaning we can take, once the balance is taken away from, make sure you subtract from whatever that amount was. So that's kind of just a walkthrough of what all I have here. It's a super simple contract. I don't want to get into anything too complex, but that's just like super high level, a super high level view of what a contract would look like. Now we're going to actually deploy the contract. So I have my environment here connected to to my MetaMask, making sure that, now I'm on the Rinkeby test network. It's probably not the best thing because Rinkeby is going to be deprecated soon, meaning because of the merge, it's going to be taken away. But there are other test networks that you can use: Robston, Kovan, Goerli, whichever one you want to use. I just use Rinkeby because. So we're going to go ahead and actually deploy this contract. What I love about Remix is that they actually make it super easy for you to actually deploy a contract, even like if you wanted to go take it to mainnet. So what this IDE, this in-browser IDE does, it makes it easier for even just a normal person. You could just copy a contract and deploy it to the blockchain with relative ease. So I'm going to hit deploy here, and it's going to ask me about a little bit of gas, and I'm going to confirm the transaction. Now what you'll see down here is it's going to say, hey, do you want to actually view this contract? Because right now it's pending. The contract is pending. So we see right here in our MetaMask that, hey, there's a transaction going. It's working. So it looks like the contract was deployed and the transaction was completed. They're going to ask me, do I want to view it on Etherscan? Now we get to see and take a look at it on the blockchain. So now we see here on this Etherscan.io, Rinkeby Etherscan.io, whatever you decide to use, maybe Polygon Scan, whatever you pretty much everybody has like their own little block explorers where you can see their ledgers. So we have the transaction hash. Don't let all these numbers confuse you. What we're mainly focused on is this contract address, because this lets us know that we actually have a successful deployed contract. Now we can actually go to this contract. And this is why I say that, yeah, you can do certain things to actually alter a smart contract, but every single time you deploy, you're going to get a new one of these contract addresses. And that's going to be the telltale sign that something changed. Hey, we may have changed something here because the contract addresses are different. So right now we see that we have this balance function here, and if we even go back to our our Remix editor, we have the same thing here. The balance right now is 0 because there's nothing in the contract right now. But what I'm going to actually do is I'm going to I'll switch networks. I have about 0.2 of Rinkeby test ETH in here. I'm going to actually send some funds to the smart contract. So then what I need to do is I need to come back here. I need to grab this contract address. And then I want to go to send. And then I place the contract address in there because I'm about to send some funds to the contract, because basically this contract is a fee collector. Let's just say somebody is making a transaction and we're some type of escrow holding for somebody. So they send the fees to here. I say I want to send 0.1 ETH. And then I think because this MetaMask, the way this MetaMask is, I can't get to the confirm button. Let's see. Oh, here we go. $0.1. Oh man, don't do this to me. Yeah, I think it's because of the way that the let's try it on this one. So I always like that on demo day, just things like to break when it's time to show people something. Yeah, I don't know why. Let's see. Maybe if let's see, send 0.1. Yeah, it's not allowing me to scroll. That's why it's not. Let me see. No. Dang, that's so annoying. I think it's the size. Let me see if I go to system preferences. Is there a way to change like the display, the way the display is? Let me see. Maybe go to 1080. That's going to be a little bit smaller. But just for this purpose, yeah, there we go. Oh, you can't see it? There we go. Okay. Awesome. Okay. So yeah, I think because the display was so close, it was blocking out this next button, and it doesn't allow me to scroll. MetaMask has to get better with their UX. It's horrible right now, but that's just another story for another day. So I'm going to send 0.1 ETH to this contract. I'm going to hit next. It's going to ask me for some gas. I'm going to hit confirm, and then the transaction is going to start. And then we'll give it a minute while it's pending. And now we have a successful transaction. Now if we go back to the contract, we can see here that our balance is updated. Now we have 0.1 Ether in here. And if we go back to Remix, we can see that we have this 1 bajillion, it's measured in Wei. That's another topic for another day as well. But now we have an updated balance in here, and we can do whatever we kind of want with it. We can use this withdrawal function if we want to send it to a different address, but we're going to check something really quickly. Let's say that I did want to send just what's in here. Going to grab the amount. Let's say that I wanted to send it to this account. If I go back to this one, if I try to transact while I'm on here, it's going to give me an error. It's that error that we put in our contract, that check that said, hey, only the owner can actually withdraw funds and send funds somewhere else. So these type of checks are super important when it comes to just like, that's why you see a lot of hacks. There's a lot of things that may go by miss. There's a lot of required statements that may go missed because, you know, there's some things as a developer, you know, that some things you kind of just, you don't think about, and there's somebody else who comes along with a better hack and says like, hey, gotcha. And they take everything. But that's why smart contract security is super important. Getting contracts audited is super important so that they can actually check things that may not be, that you may look over. So now we'll go back and cancel that transaction. Instead, we will go over to the account that we actually deployed with, and then we'll transact. Now MetaMask allows us to actually transact, and we don't get that error anymore because this is the actual owner, and this is what we said we wanted to happen. We wanted to say that make sure that the contract address matches the same as the owner who deployed the contract. Now we can confirm this. And again, we can go on Etherscan and see the transaction. If we come back here, we can check the balance again. We see now that the balance is 0. And if we go to that account that we sent it to, now they have 0.1 ETH. Super simple. Like I said, just a super high level overview of smart contracts and how they actually interact and operate together. These small things right here are super important because they're pretty much how we're operating and how we're creating things, the things that we're creating right now. If you do want to actually dive a little bit deeper into smart contracts and learning a little bit more, here's a few resources that I do recommend. Use web3.xyz. They're super good. They have like a variety of things. They're not just like a smart contract development website. They have like podcasts, articles, all different types of things that you know, that can teach you about Web3. Learn web3.io. That's a super good one as well. They pretty much take you from like the start of blockchain, and then they take you even just like through code and things like that and bring you up to speed to kind of where we are now. Speedrun Ethereum is a little bit more advanced. It's by a guy named Austin Griffith. It's super good if you kind of have a little bit of coding chops. It's good to get into just to learn a little bit more. And then buildspace.io, this was kind of how I got introduced and onboarded. It's pretty much copy and pasting code. You create your own NFT, and then you can just kind of take that code and do anything that you want with it. And that's pretty much it. If you guys have any questions for me, I'll be around. I know we're kind of just like behind on time and things like that, so I'll make room for the next speaker. Like I said, I'll be here if you want to talk smart contracts. Or I'm not an expert, of course. We're all still learning in this space, but I'll try to help out and answer any questions that I can. So I appreciate you guys. Thank you guys.